What's going on, everyone? My name is Johnny Bandon, and I'm your CCNA instructor for these CCNA video series. And in this video, we're going to be going over our inter-VLAN routing. So we just got done with our inter-VLAN routing lecture, where we learned how to configure our VLANs, which are logically segmented at layer 2, and we just learned how to configure them to actually be able to have layer 3 reachability or IP reachability. So we're going to go into our CCNA video course, and for our paid students, the ones that go on our website and pay for the course, or the ones in our virtual training, these labs are going to be available to you. So you'll have this CCNA video course in our central repository on our course. So if you go to section 4 here, you're going to see the ROAS Lab 1. So that stands for Router on a Stick, Lab 1. And we're going to open up this lab. And the first thing we're going to do, right, is go ahead and start all these nodes. So for our paid customers or students, and for anybody watching on YouTube or any other free streaming service, what is available to you is always the instructions here at our GitLab, which should be in the link in the description below if you're on YouTube, where you can come here to section 4, instructions, and come here to the ROS, Router on a Stick Lab. And in here, you're going to see a network diagram, just a screenshot or really a clip of this environment here on EVE-NG. And then we have our instructions. So I'm going to drag that over to the monitor on my right, which isn't in view of you guys. And I'm going to go through these instructions, and we're going to configure this lab. So step 1, turn on all devices, which we have done. And then step 2, paste baseline from the GitLab. So what we're going to do right now is go ahead and console into all these devices. My native console is Secure CRT, which I suggest we all use, right? Secure CRT is awesome. And for you guys on our free course, you'll have to go ahead and paste the baseline in from GitLab, which if you come to the root of the repository, we have a baseline for the Cisco iOS versions we're using, which are called iOS or IOL, which stands for iOS over Linux. That's what I use for all my labs. But that baseline should work for any really Cisco iOS you're virtualizing in an EVE-NG or GNS3 environment. All right. So let's go ahead and log in to all these devices real quick. We'll do this one at a time. It is possible to do this all at once with Secure CRT. With the menu bar down below, you can put a command window, and then you can come in and say send commands to all sessions. And then if we type in CompT, it's going to go ahead and do that on every single one. But we decided to do it individually because not everyone's going to have Secure CRT, right? So now let's dive in. So step 3 is going to be verify. So what we're going to do right now is just go through our switches and our routers and verify that the VLANs and the trunks are created. So actually just going to go ahead and do it on our switches. So we're going to type in do show interface trunk. And yes, we do have trunks created on switch 1 going down to switch 2 and switch 3. We're going to type in do show VLAN brief. All of our VLANs are created, and even though there's no users connected, it's still important, right? Do the same thing on switch 2. Our trunks are created, 0-1 going up to switch 1. 0-0 going over to switch 3, and then type in do show VLAN brief. VLAN 20 is configured on 0-2, which is correct. And VLAN 30 is configured on Ethernet 3, which actually isn't correct. That should be VLAN 10, right? So let's go ahead and fix that real quick. So good thing we verified, right? Switch port access VLAN 10. And no, that wasn't a test. I was honest in an honest configuration error. We'll do this on switch 3 as well. Okay, our trunks are made. And then type in do show VLAN brief. And hopefully this is configured correctly. So we have VLAN 10 on ETH01 and VLAN 20 on ETH03. Awesome. Okay, so now step 4, create a trunk from switch 1 to R1. So before we jump right into the configuration steps, let's go over our network here, and let's just kind of go over what's going on. So as we see here, we have VLAN 10, VLAN 20. they have their own subnets here, and they're logically segmented with these VLAN IDs or VLAN tags. So PC7 down here should be able to communicate to this PC over here, right? Because they're in the same VLAN and these trunks are working. Now, this PC and this PC, both in VLAN 20, they should also be able to talk to each other. They should have reachability. Even without a default gateway, right? Because we should still be able to be in that /24 network, send broadcast out, and figure out our neighbors with ARP, right? But these VLANs can't talk to each other because they're segmented logically via layer 2, and they're a part of a different subnet. So now what do we need to do to ensure that these VLANs can talk to each other? We need to install some sort of layer 3 device that can route, keyword route, between these subnets. Because that's what a router does, right? It routes IP traffic between different networks or separated segmented networks, okay? So in this lab, we're going to use router on a stick, which uses sub interfaces that are going to be able to read the encapsulation.1q VLAN tag. And these are going to be logical interfaces. And physically, the traffic's still going to come on ETH00. So we're going to make sub interfaces on ETH00, which we learned about in our lecture. And then we have this VLAN 30 over here for management. So if you take a look at the diagram here, we don't have users in the management VLAN. Well, do we not have a CEO or bosses? And that's not what we mean by management, right? What we mean by management here is that these switches are acting as pretty much access switches. They're just pure layer 2. So let's say this network is in Arizona. It's a spoke or like a small office, but our headquarters is over here in New York. And we have our big hub router, and these routers are connected via the big cloud right here, an ISP. Well, how is our network operations center going to be able to SSH or remote in to this switch? You can't do layer 2 across the internet, right? That's what IP addressing is for. So what this VLAN is for management of our network devices. So what we're going to do is create SVI 30 or interface VLAN 30 on each of our switches. And we're going to also create that sub interface up here so that these switches have reachability out to the internet and that we can remote in and these switches can now be reachable. Also, in case maybe we're local here and we want to SSH from our office, right, into these switches. Maybe we're a local network admin and we don't need to go console into the our data center, or maybe this office, our comms closet, right? So awesome. So we're creating sub interfaces on our router, and we're only creating one SVI on the switches, and that's interface VLAN 30, and that's so we can remotely manage our network devices, which is our switches. So now with that being said, let's jump into the configuration. So on that connection from that first downstream switch up to our router, our layer 3 device, it's going to be a trunk, okay? So let's go ahead and create that, and that's our 4th step. So it's going to be interface ETH00, I believe. And switch port trunk encapsulation.1q, switch port mode trunk, and then we're going to do switch port no negotiate just for fun, right? It's just kind of what I always configure on my trunks. And then step 5, on R1, we're going to create sub interfaces for each VLAN. So for this, we're going to need the VLAN's information, the IP address information. And then we also are going to need to know which physical interface. So let me show you guys something. So if we're very hasty, we want to jump right in to configuring our sub interfaces. This is how we do it, right? So we created sub interface 00.10. And remember, this .10 doesn't matter, okay? This is just administratively what we see, like when we want to see what interfaces we've created, this is what we see, okay? Doesn't have any correlation or any effect on the routing for devices in VLAN 10. This, however, does encapsulation.1q10. This right here, this command is going to place this sub interface into the VLAN 10's network, right? So any packet or any frame that this router receives on ETH00 with a VLAN ID of 10, it's going to be placed into this subnet, or it's going to know that it's part of that network, which we're about to place on this interface, which is 192.168.10.1. Oh, /24, of course. And then no shut. Now let me show you guys something real quick. We are creating a logical interface here at this sub interface. However, physically, at a hardware, at the data level, we're still receiving that traffic on the physical interface of ETH00. Now, I know we kind of get lost in the matrix here in Event G, but in a real world network, that's a physical device, that router here. So let's look at our show IP interface brief. We can create sub interfaces all day long, but we're going to get no network connectivity because this physical interface 00 is still down. So my first step when creating sub interfaces or doing router on a stick is go into the physical interface. I like to give mine a description and turn it on, right? No shut. And now those sub interfaces will be able to work. So again, let's jump in here, create our next sub interface. And we're going to do this for VLAN 20. And let me show you what happens here if we try to give this sub interface an IP address. Now remember, this technology, sub interfaces, router on a stick, the whole point is to route or do inter-VLAN routing, right? So when I create this sub interface, in the code or the logic of this router, it knows that it's doing traffic for VLANs or something tagged with an 802.1q VLAN ID tag. So if I try to put an IP address on this sub interface, before I give it the VLAN tag that it's supposed to be routing traffic for, it's going to give an error saying we need to be part of an 802.1q or ISL VLAN first. So first thing we got to do is that encapsulation.1q command. And then we can up arrow back to our IP address command and we'll be good to go. Also give this a description here, VLAN 20 engineering. I'm going to go into my other sub interface I created and do the exact same thing. VLAN 10 sales. Okay, and then this next sub interface, just to kind of beat that point home, we're going to create a different sub interface here. And we're going to make it part of VLAN 30. Just to show you that this dot here, this logical number, really doesn't matter. What matters, again, is this command and the IP address command that comes after it. Okay, awesome. So let's do a couple show commands here. So we see our show interface description here. We can see quickly what these sub interfaces are for. You see, we don't know what this one is for. So kind of annoying, right? If we kind of want just quick administrative action on this router, we want to say, okay, this sub interface is for this VLAN. That's why these descriptions should always be used, right? It's kind of like commenting code, right? For software developers. The guy coming in after you or your counterparts want to know what's going on, right? And they want it to know it quickly without having to do a deep investigation. Okay, VLAN 30 management, give that a description. Do show IP interface brief. Okay, awesome. Now, step 6, for each switch, let's create a management SVI. So I'm going to show you guys that configuration. So the first thing we're going to do when creating a management SVI on our switch is I'm going to show you guys something. So on a typical switch or a catalyst switch, you usually will already have configured interface VLAN 1. Now in this EVE-NG emulated environment, you don't see that. But when I teach CCNA, I like to bring real world stuff into my courses. In a real world environment, some switches, I think it depends on iOS version, to be honest, because I haven't worked on every Cisco switch, so I don't want to put a blanket statement on there. At least the ones I've worked on, there's interface VLAN 1 already created and up. And that will sometimes affect which SVI the switch chooses to be its default one for routing traffic, right? We want to use interface VLAN 30. So even though it's not needed in our virtual environment here, here's how I would do this in the real world, is I'd go into that already created interface VLAN 1 and shut it down, right? And then I'd go in and create interface VLAN 30. description, management, SVI, and I'd give it its IP address. We're just going to go one up from the default gateway. And we also have to no shut just like we would, let's say, a routed interface or layer 3, right? Okay. Next thing we're going to do is go, well, actually, before we do that, we're going to type in IP default gateway 192.168.30.1. Now, this is just an extra command that allows us to actually reach out. So what do we mean by that? So we need to tell this switch where its default gateway is, because right now it wouldn't know just from this information. Just like when we are on a PC, we need to give it a default gateway, right? So this is going to allow us to reach beyond just our LAN, okay? Now we come here to switch 2. We're going to do the exact same thing, guys. So interface VLAN 30, description, management SVI, IP address 192.168.30.3. We're going to no shut. And then we're going to type in IP default gateway 192.168.30.1. Come here to switch 3, do the exact same thing. Description, management SVI, IP address 192.168.30.3 with that /24. And of course, we have to no shut, turn it on. And then we're going to tell it the default gateway so we can reach beyond just the LAN. And I forgot, we also, right, real world, pretending like we're the real world, shut down interface VLAN 1. Awesome. So now, let's say we wanted to SSH from switch 1 to switch 2. Is it possible? Let's try. So how do I figure out the IP address of switch 2 if I didn't already know it or have it diagrammed? It'd be show CDP neighbors. I can see switch 2 is on ETH01. So show CDP neighbors ETH01 detail. And I see its IP address here is .3. So now I can type in SSH, TAC L. Our username is Cisco. Oh, I went to .2 on accident, but that's okay. That's just going to SSH to ourselves. Let's try that command one more time. We'll exit out of here because right now we're SSH to ourselves. And let's go into switch 2. Awesome. And now if we want to go to switch 3 from here, we could do the exact same thing. You see that? And we're using the VLAN 30's IP addressing to make that happen, right? Let's see here. Why can't we see it? Because it's a duplicate on switch 3. That's my fault. Come back into here. IP address 192.168.30.4. Okay, and usually we would see some error messages with that. We had a duplicate IP address out there. Maybe we would on our router. No? Okay. But as you can see now, we can SSH between our switches, right? Now we have reachability. So for our final test, let's go ahead and test reachability between VLAN 10 and 20. So let's do that from router 1. So what we're going to do here is just do some quick tests, okay? So we're going to try to ping PC10. Okay, we're successful. Does this mean that we've fully tested inter-VLAN routing capability? No, it doesn't. And I'm going to show you that with the Wireshark capture. So if we capture here on ETH00, when we ping .10.3, what do we think our source address is? Do we think it's going to be this sub interface here, this one, or this one? Let's test it out. And we see that we just did a ping within the same subnet, right? That really didn't prove much. It proved that our LAN was configured correctly. But let's try to ping this from a different source. And now if we come back to our packet capture, look at that. It sourced it from VLAN 30's IP address. So now we know, at least from the router, we have reachability between our VLANs, and we can even test that with VLAN 20. And boom. So if we jump into this PC here, and if we just go ahead and ping 192.168.20.1, now we know we can reach the VLAN 20 subnet. So now we know we've configured inter VLAN routing correctly. Awesome. So that's going to be it for this video. I hope you guys found this informative, and stay tuned for our next video. We're going to go over SVIs and how we can do inter VLAN routing just with a multi-layer switch.